In this lesson, we'll learn about vSphere standard switches, and we're really going to focus on a lot of the policies that you can configure. This is one of the objectives of the VMware Certified Associate exam, is to be able to identify and explain these different virtual switch policies. So that's what we're going to take a look at here, is the different virtual switch policies that can be created on a vSphere standard switch. And one of the first policies covers how do we handle the failure of a physical network adapter. Right? So VMnics are the physical adapters of the ESXi host, and each VMnic can only be assigned to a single virtual switch. Virtual switches cannot share VMnics. So in this slide, we see a virtual switch with 3 VMnics. And our network is currently in a healthy state. So all 3 of my adapters are connected. They have a nice green link light and everything is working properly. And I've got this virtual machine on the left, and the traffic for this virtual machine is currently flowing through the first adapter. Now, let's say that we have some sort of problem, like maybe somebody is cleaning up some cabling for us and they cut the wrong cable. Right? And that network connection that's currently being used by this VM is now down. Right? So at this point, this VMNIC, this physical adapter, has lost connectivity. Right? It can't connect to the physical switch, and so my VM is going to be affected as a result because my VM was using that physical adapter. Right? But this is actually a really easy failure for the ESXi host to detect. And when that connection fails and that link light changes from green to red, the ESXi host will simply migrate the traffic of that VM to a different physical adapter. Right? And so there's a few different policies that we can configure that will control, number one, how traffic fails over from one adapter to another. And number two, how traffic is load balanced if we have multiple VMnics available. And that's what we're going to take a look at now. So our first policy is called NIC teaming by originating virtual port ID. And in this scenario, what we have here, and by the way, this is the default option for a virtual switch. So what we have here is a virtual switch with 1, 2, 3, 4 VMnics, 4 physical adapters, and I've got 3 virtual machines. Right? And so my 3 virtual machines are all going to be generating some network traffic, and I want to equally distribute that traffic across these 4 physical adapters, these 4 VMnics. So the way that NIC teaming by originating port ID works is each virtual machine is connected to a certain port on the virtual switch, and based on the port that it's connected to on the virtual switch, that VM will be tied to a specific physical adapter, a specific VMNIC. Right? So for VM1, all of its traffic as it flows out to the physical network is going to be handled by VMNIC 1. For VM2, VM2 is connected to a different port on the virtual switch. So therefore, it'll use a different physical adapter. We'll just call it VMNIC 2. Right? And for virtual machine 3, that's connected to yet another virtual port on the virtual switch. And so what the virtual switch is essentially doing here is it's saying, as each VM connects up to a different virtual port, we're going to tie each VM to one specific physical adapter, and any traffic for that VM that needs to hit the physical network will flow through that one single physical adapter. Right? So any traffic for VM1 is always going to flow out of VMNIC1. Now, if VMNIC1 were to happen to fail, then at that point the ESXi host would modify this and basically tie VM1 to a different port. Another option is NIC teaming by source MAC hash. So if you don't know what a MAC address is, every virtual machine has a unique layer 2 address called a MAC address, right? And just think of it as a unique identifier that every single virtual machine has one of these. And MAC hash works pretty similarly. What it basically does is, based on the MAC address, each VM is tethered to a physical adapter, right? So this particular VM has, we'll call it MAC address 1, even though it would be like a large hexadecimal number. Based on that, that virtual machine will be tied to a specific physical adapter. And as we kind of go down through the remainder of our diagram here, we can see basically the same thing is happening as happened in the previous slide, right? Each VM is being tethered to a different physical adapter. The only difference is it's now based on the MAC address and not based on the originating virtual port. And again, if one of these physical adapters were to fail, the virtual machine would be dynamically migrated to, another physical adapter, again based on the MAC address. Now, what these first two methods have in common is that basically the way it's set up is each virtual machine is bound to one specific physical adapter, right? So if we look at VM1, for example, VM1's traffic is always going to go out of adapter number 1, right? That's always where its traffic is going to flow, right? If VM1 has a ton of network traffic, let's say it's like an FTP server or something like that, it can never use the bandwidth of VMnic 2 or the bandwidth of VMnic 3, right? We can't distribute that virtual machine's workload over multiple physical adapters. It doesn't work that way with source MAC hash, and it doesn't work that way with originating virtual port ID. IP hash is a little bit different. Right? IP hash distributes traffic based on source and destination IP, right? So for example, if this virtual machine is generating some traffic towards a destination that we will call, destination 1, right? Destination 1 has its own unique IP address. So based on the source IP and the destination IP, a physical adapter, in this case, VMnic 1, will be chosen. Now, if this virtual machine also generates some traffic to some other destination, well, again, the VMnic used is going to be based on the source IP and the destination IP, right? So because this traffic is flowing to a different destination, it's going to be load balanced across a different physical adapter, a different VMnic. And now my virtual machine is actually able to utilize the bandwidth of multiple physical connections on my virtual switch. So that's NIC teaming by IP hash. Now, there's a lot of other considerations that go into this that we kind of start to get into in the vSphere Foundations course. But you need to think about things like ether channel and trunk ports, and there's a lot of other considerations that go into choosing the appropriate NIC teaming method. But as far as the VMware Certified Associate exam goes, you just want to understand these at a high level. And we've really gone into enough detail here for the associate level certification. Another policy that you can enable is called traffic shaping. Right? So for example, with traffic shaping, what we're doing is we've got this virtual machine that's part of a virtual machine port group, right? And on this port group, we can identify certain traffic shaping characteristics, like what is the peak bandwidth allowed per virtual machine and what is the average bandwidth allowed per virtual machine. And the goal here is essentially this, right? We might have a whole bunch of VMs on different port groups all connected up to this vSphere standard switch. And if this one VM happens to be really network intensive, it could chew up a ton of bandwidth, right? Or if I have like a bunch of VMs that are on my development port group and we're testing something out, well, they could potentially chew up all of the bandwidth for that particular vSphere standard switch. And now all of the other VMs connected to that vSphere standard switch will suffer as a result. Right? That's the purpose of traffic shaping. We're implementing basically some maximums. We're saying that if a VM is on this port group, we've identified, hey, at any given time, each VM can generate this much traffic peak and this much traffic on average over the long term. That's what it's got to average out to. So that's how traffic shaping works. It's just a way to make sure that like a noisy neighbor type situation doesn't occur where one small subset of virtual machines is using all of the bandwidth. Again, much more on this in the vSphere 6 Foundations course, or I should say the vSphere 6.5 Foundations course. But for the purposes of the VMware Certified Associate, you just want to understand that traffic shaping is a way to ensure that a subset of VMs does not use all your bandwidth. And then there's a number of security settings that you can configure as well. They can be configured at the virtual switch level or at the individual port group level. And we can set up things like forged transmits, MAC address changes. And with forged transmits and MAC address changes, what we're doing is we're allowing MAC spoofing. If we want to allow our virtual machines to use fake MAC addresses that don't match up with their virtual NIC, we can do that. And we can also use security settings like promiscuous mode if we want to allow a sniffer to be attached to our network. So again, for the VMware Certified Associate exam, you really want to understand the fact that these security policies can be modified to basically harden our network, make it more secure, and that they can be controlled either at the virtual switch or the port group or even at the virtual machine level. Okay, so in review, we learned that virtual switches can be protected from NIC failures using a variety of NIC teaming methods, which also are utilized to load balance traffic as well. And different NIC teaming methods balance that traffic differently. So with originating virtual port ID and source MAC hash, we saw that each VM was basically tied to one specific adapter based either on the original virtual port or on the source MAC hash. Whereas with IP hash, we saw that virtual machines could actually take advantage of the bandwidth of multiple physical adapters, and it's based on the source and destination IP